Hello everyone. Today we are going to start our new lesson, Empirical Formula and Molecular Formula. So before starting the lesson, I would like to describe I would like to compare both empirical formula and molecular formula and what are their significance in calculating this formula. So basically molecular formula, as you also studied in your previous classes, that this formula is basically used to find the actual number of atoms within a compound or molecule, or this formula shows the actual or real number of atoms within a compound or molecule, most specifically molecules. Okay, so on the other hand, the empirical formula it shows the ratio, okay, simplest ratio, most specifically, okay, simplest ratio of atoms within a molecule. Okay, so suppose for example, take the example of molecular formula that H2O, water. Okay, here it means that water consists 2 atoms of hydrogen and 1 atom of oxygen. Whether this molecule is in the form of gas, or whether this molecule is in the form of solid or liquid. In all these 3 states, the amount of the atoms within molecule would be the same, that is 2 into 1, 2:1. Okay, is that clear? So this compound or this molecule have the same, its molecular formula and empirical formula is that of the same. Okay, simplest ratio. On the other hand, there are some larger molecules. For example, molecular formula of CH3COOH, acetic acid. Okay, we can also write this in this form, CH2C2H4O2. Okay, it shows the actual number of atoms within the compound. But if I want to write this in the form of empirical formula, I will simply write the ratio. Okay, for example, C1. Okay, simplest ratio 1:1. So H2O. So this formula, the simplest or the empirical formula of acetic acid would be CH2O. Okay, and the ratio would be 1:2:1. Okay, all the 3 elements, that is carbon, hydrogen and oxygen, would have this ratio. Okay, 1, 2 and 1, sorry, 1:1. Okay, so the composition of carbon, hydrogen and oxygen in this compound is 1:1, the percentage composition or the ratio of these 3 elements. Okay, on the other hand, if you see water, empirical formula of water will be the same. Okay, both empirical formula and molecular formula of water is the same, that is 2:1. Elements, hydrogen and oxygen, they are present in the water molecule into 2:1 form. Okay, whether it is in the form of gas, liquid or gas, whatever. Okay, but there are some large molecules like acetic acid, say for example octane. Okay, they have the very large number of atoms. Okay, so you can see over here 8 atoms of carbon and 18 atoms of hydrogen. But if I want to write this molecular formula of octane, okay, I will write this like I will write this in the simplest form, that is I will find the smallest ratio. I will divide both the atoms with the simplest number that can do. Okay, so C4H9. So this is the empirical formula for octane. Is that clear? So on the other hand, molecular formula. Okay, molecular formula, keep in mind that molecular formula and empirical formula for some compounds, they are same, okay? For some compounds, these are same, okay? Both empirical formula and molecular formula. These are number one, these are ionic compounds. All the ionic compounds consist of salts, it consists of acids, and it also consists of bases. Their empirical formula and molecular formula, these are all would be the same. They have same empirical formula and molecular formula. Is that clear? So ionic compounds, their molecular formula and empirical formula are same. For example, sodium chloride, salt, okay? Sodium chloride, for example, hydrochloric acid, okay? For example, let's suppose sodium hydroxide, okay? Sodium hydroxide, magnesium hydroxide, okay? Their empirical formula and molecular formula would be the same, okay? But keep in mind that organic compounds, their empirical formula and molecular formula would not be equal, okay? So empirical formula of organic compounds, it is not equal to its molecular formula. As I told you, as I give you the example of octane, okay? And it's okay, and I also give you the example of acetic acid, okay? The third thing that you need to keep in mind is that molecular formula of the small covalent molecules, okay? Small covalent molecules, their empirical formula and molecular formula are also same. Say for example, water, it's a covalent molecule, okay? But still its molecular and empirical formula are same. For example, carbon dioxide, okay? For example, nitrogen and 2, okay? Pure covalent molecule. For example, oxygen, O2, pure covalent molecule, its ratio, it's both empirical formula and is the same. For example, let's give me an example like sulfur dioxide, okay? Pure covalent molecule. On the other hand, there are many small molecules, and these small covalent molecules, their empirical formula and molecular formula, they are same. And large organic compounds, they have their empirical formula and molecular formula are not same, and we have to calculate, we have to convert them. And ionic compounds, they're like salts, acids and bases, they have different empirical formula and molecular formula. So their example in your book, okay? Rules for calculating molecular formula, okay? Before we go to the examples or calculating or reducing the formulas, we need to understand the rules for finding the molecular formula or somehow empirical formula. If percentage is given in the question, you need to convert the percentage composition of elements within a compound into gram weight, okay? So you need to convert the percentage into gram weight, okay? Is that clear? Then convert gram weight into moles. Then if we convert the gram weight, if we convert the percentage into mass, then we will convert that mass into moles. And we know what is the formula of moles, that is N into weight into molar mass of the element, okay? So here you need to convert the elements, percentage composition, percentage of elements of the compound into gram, then after gram into moles. And then you have to find the molar ratios, okay? Then convert those molar ratios into simplest molar ratios by dividing them with the smallest ratio. Then deduce the empirical formula, then find the empirical formula mass, okay? Empirical formula you have to find, okay? Then find the coefficient of molecular formula, also called factor, okay? It's also called N factor, and it is shown by N, small n. you have to find the coefficient for molecular formula. Very important step. And the formula for this is molecular formula mass divided by empirical formula mass. This is the formula for calculating the factor for molecular formula. Okay, if the molecular formula of mass is given in the question, then you just need to divide the molecular formula mass over the empirical formula mass, and you will find the factor or coefficient for molecular formula. And after that, you have to deduce the molecular formula by multiplying the n factor. We will multiply the n factor with the empirical formula. Okay, so these are the 8 rules for calculating the molecular formula. And let's do the questions related to the finding the molecular formula. Okay, there is a question in your book that a carbon compound P, okay, unknown compound, has the percentage composition 85.7% carbon and 14.3% hydrogen. Its relative molecular mass was found to be 56. So calculate its empirical formula and molecular formula. Okay, now first of all, we need to convert the percentage into percentage into gram weight. Okay, so here you can see over here we have carbon compound P and unknown compound, and we have carbon and hydrogen. Okay, I will put the ratio over here. So percentage is given percentage is that of carbon is 85.7% and that of hydrogen is 14.3%. Is that clear? In the first step, you have to convert percentage into mass or gram weight. Is that clear? So here I will take it 85.7 gram or 14.3 gram. Why I did this? For example, if you take 100 gram of this compound, it will definitely consist 85.7 gram of carbon and 14.3 gram of hydrogen. Logically, if you think logically of this, 100%, within 100%, 85.7% is carbon and 14.3 is hydrogen. In the same, if you take this 100 gram, if you consider this 100% as 100 gram, so we have to consider the percentage as their gram. Is that clear? So we need to consider as percentage, given percentage of each element in the compound as their gram. Okay, so in the second step, we have to find the Molar ratio. Okay, and we need to convert the for this we need to convert the given weight, okay, into their moles. We have to convert them into moles. So we know that our atomic mass of carbon is 12 and that of hydrogen is 1. So 85.7 gram divided by its atomic mass, because we need to find the moles of each element. 14.3 gram of hydrogen will get divided by 1. So the molar ratios, it would be 85.7 divided by 12. It comes out to be 7.14, okay, moles, and that of 14.3. Now we need to convert, find them. The third step, simplest molar ratio. You have to find the simplest molar ratio, and for this we need to divide all the ratios with the smallest ratio, and the smallest ratio is 7.14. So 14.3 divided by 7.14, it comes out to be 2, and here it is 1. Okay, because I divide all these value with the smallest ratio. Okay, simplest molar ratio is 1 into 2. So we'll deduce the empirical formula empirical formula here, it comes out to be ch2, one atom of carbon and 2 atom of hydrogen. The fifth step, we have to find the empirical formula mass. Okay, so this is part A. Part A calculation has been, that is calculates empirical formula. We have completed this. Now we have to find the molecular formula. Next step, we have to find the empirical formula mass. Okay, we know that empirical formula here, 1 atom of carbon is there and 2 atoms of hydrogen. So we need to find the mass of carbon. Empirical formula mass is equal to, we know that 1 carbon and 2 hydrogen. So 12 plus 2, it comes out to be 14. So empirical formula is 14. Okay. The next step, molecular formula. Molecular formula mass is given, that is 56. Okay, and we have to find the factor for molecular formula, and that is equal to molecular formula mass divided by empirical formula mass. So here it is, we get 56 divided by 14, comes out to be 4. So 4 is the factor, and the next step, in the last step, we have to multiply. For finding the molecular formula, we have to multiply the n with empirical formula. Okay, and n is 4. 4 is going to multiply with ch2. Okay, so here it would be C4H8. So this molecule is actually ethene. Okay, ethene molecule. Is that clear? So we have deduced the molecular formula of the unknown compound through the percentage composition. The same way, there is also a question like composition of hydrocarbon. Okay, the same composition is given for you. Okay, percentage composition of carbon and hydrogen is given for you, and that is hydrogen is 10% and carbon is 90%. Okay, so definitely in the first step we have to convert the percentage into gram, that is 90 gram into 10 gram. Then we have to find the molar ratio. Okay, molar ratio, and for that we have to divide all the weight into their atomic masses. So 10 will get divided by 1. Is that clear? So here 90 divided by 12, it comes out to be 90 divided by 12, 7.5. 7.5 into 10. So simplest molar ratio, the next step, simplest molar ratio. So 7.5 divided by 7.5, that is carbon and hydrogen, and here 10 will get divided by 7.5. So 1 into 10 divided by 7.5, 1.33. Okay, so simplest molar ratio, again it is a decimal, it is not a whole number. Okay, so we have to convert, in order to convert them into a whole number ratio, we have to remove the point. We have to convert the decimal number into whole number. Okay, so for this we have to multiply any number with the ratio. So 1.3, if I multiply this with 2, it comes up to be 2.6, which is not correct. 1.3 multiplied by 3, 3.99. So 1.33, so 3 into almost 3 into 4, it comes out to be like this. Multiply by 3, 3.9. So it comes out to be 3 into 4, 1.33 multiplied by 4, So C3H4, this is the molecular, or this is the empirical formula. C3H4. Is that clear? In the same way, there is another question. Hydrocarbon Z is composed of 80% carbon and 20% hydrogen. Okay, so again we need to convert all these into their percentage composition, into gram weight. So percentage is given, that is 80% into 20%. Okay, we have to convert them into gram, that is 80 gram of carbon and 20 gram of hydrogen is present in this compound. So Molar ratio 80 will get divided by 12 and 20 by 1. So if you divide 80 divided by 12, 6.67, and here 20. So 20 divided by 6.67, it comes out to be simplest Molar ratio. The next step, simplest Molar ratio, 6.67, 6.67. It comes out to be almost 1 ratio into 3. So empirical formula over here is CH3. Now empirical formula mass, that is equal to 12, 1 atom of carbon plus 3 atom, 12 plus 3, 15. 15 is the empirical formula mass of the compound. And molecular mass, molecular formula mass is given, that is 30 gram per mole. Okay, so the N factor for, or coefficient or factor, it would be equal to, we have to molecular formula mass divided by empirical formula mass. So here it would come out to be the factor, or N. It comes out to be 30 divided by 15 is equal to 2. So our molecular formula would be 2 into CH3, that is C2H6. This is ethane molecule, C326, 2 to 4 plus 2, ethane molecule. In the same way, there is a very important question and a very lengthy question as well. You have to find the molecular formula of each of these compounds. A table is given for you, okay, and there is no percentage composition, there is no gram weight. Simply they have given you empirical formula and molecular formula. MR means molecular formula mass. Okay, molecular formula mass. Is that clear? So here, starting from A, what you need to do, you just need to find the N factor. Okay, N factor for molecular formula. Okay, because there is no percentage composition, no gram weight, you just need to find the N factor. And N factor, we know that it is equal to molecular formula mass divided by empirical formula mass. Okay, this is the formula for this. Now starting from part A molecule. Okay, we know that A molecule, it too is the molecular formula mass, and we have to find the empirical formula mass from it. Okay, so we will divide 82. Okay, there are 3 atoms of carbon, so mass of carbon is 12. There are 3 atoms of carbon, 2, plus hydrogen is 5, so 5 atom of and mass of hydrogen is 1. So the N factor would here it be 182 divided by, so 12 multiplied by 2 plus 5, 29. So 82 divided by 29 is equal to 2.87. So here the n factor is 2.87. Not 2.8 here, 3 atoms of carbon. Sorry for that. 12 multiplied by 3, 36 plus 5, 41. So 82 divided by 41, it's 2, and here is 2. So simply the molecular formula, it is equal to N into empirical formula. So N is 2 and there C3H5. Molecular formula would be C6H10. So it is actually, this molecule is hexine molecule. Okay, so the B molecule, in the same way, carbon tetrachloride, we need to find the N factor, and for N factor the molecular mass is given, that is 237. Empirical formula mass 12 plus there is 1 carbon atom and 3 chlorine atom. Mass of chlorine is given in the question, 35.5. So 35.5 multiplied by 3 plus 12 comes out to be 237 divided by 11.8.5. So 237 divided by 11.8.5, it's almost 2. And factor again here is 2. So molecular formula, it would be 2 multiplied by its empirical formula. So C2H6. C2HCl3. Let me write it again. C2Cl6. Is that clear? In the same way, you can find the molecular formula of this compound. You just need to find the empirical formula mass. Molecular formula mass is given, and after division you will find the N factor, and then you have to multiply the N factor with this formula, that is CH2. And if you are able to find it, then please comment. Please write the answer in the comment section. Here again there is a question in which 3 elements are present. Okay, the same. Okay, here carbon, hydrogen and oxygen are given. Okay, percentage composition of this X compound. Okay, this is X compound, and here carbon composition is 11.1%, hydrogen is 22.2%, and oxygen is carbon is 66.7%, hydrogen is 11.1%, and oxygen is 22.2%. We will convert them into gram weight. Okay, so 66.7 gram of carbon is present in this compound, 11.1% of hydrogen, and 22.2 gram of oxygen is present. In the second step, we have to find the molar ratio. Okay, molar ratio. So 66.7. Mass or atomic mass of carbon is 12. Atomic mass of hydrogen is 1. Atomic mass of oxygen is 16, as given in the question. Okay, so molar ratio is 66.7 divided by 12 is almost 5.558. Okay, and it would be 11.1. 22.2 divided by 16, 1.387. So the smallest ratio we have to find in the third step, simplest molar ratio. Okay, so the simplest molar ratio would be, we will divide all this value with 1.387, 1.387, 1.387. So here 1 into 11.1 divided by 1.387, it comes out to be nearly 8. Okay, and here 5.58 divided by 1.387, it's almost 4. So the empirical formula here, it is C4, hydrogen 8, and oxygen is 1. Is that clear? Now the molecular mass is given for you. You have to find the next step, N n factor. Okay, and n factor is equal to mass, molecular formula mass divided by empirical formula mass. Molecular formula mass is given, that is 72 divided by empirical formula mass. We have to find it now. So 4 atoms of carbon, 12 plus 8 atoms of hydrogen, mass of hydrogen is 1, plus 1 atom of oxygen is present, plus 16, mass of oxygen is 16. So what will we do? 12 multiplied by 4 plus 8 plus 16, it comes out to be 72. 72 divided by 72 is equal to 1. Okay, so 1 is the n factor, and if you multiply this 1 with the formula, empirical formula would be the same. Okay, so C4H8O. Okay, it can be an aldehyde, it can be ketone, it can be alcohol, any compound. Okay, so this is how you can calculate the molecular formula. Now there is a homework for you, that you need to find the empirical formula of a compound. So a compound containing magnesium, silicon and oxygen, which is present in rock types in Italy. Okay, a sample of this compound weighing 5.27 gram was found to have the following composition by mass. So magnesium is 1.82 gram, silicon is 1.05 and oxygen is 2.4 gram. You need to calculate the empirical formula. And the question is that analysis of another organic compound give the following composition by mass. Carbon is 64.86%, hydrogen 13.5%, and oxygen is 21.864%. So you need to find the empirical formula, and after that the molecular mass is 74 gram per mole. You just need to find its molecular formula. Okay, so definitely you have to find the n factor, and after that you can easily find the molecular formula. So these 2 questions are your homework, and practice these 2 questions, and if you are able to do so, then answer of this question in the comment section.